In this video, we are going to look at the second use of a potentiometer, that is to compare the EMFs of two cells. So this is the circuit diagram for it. Okay, this is the battery, all right, and AB is basically the potentiometer. To this point A, we have two cells connected like this. All right, so two cells connected. R1 and R2 are the respective internal resistances of E1 and E2, and we have two keys, K1 connected to the first cell and K2 connected to the second cell. Okay, then after we have the galvanometer connected, to which is connected the jockey. By the way, I forgot to tell you all one thing. In all potentiometer circuits, okay, in all potentiometer circuits, you have to make sure that as you can see in this picture, to this point A, we have the negative side of the battery connected. Now to this very point A, we have to have the same negative side of the cells connected, remember. And likewise, point B is connected to positive, of course. Okay, so the same positive polarity has to be connected to the point B. Okay, this is the intro picture of potentiometer that I had showed you in my previous video. So you can see in this picture also. So negative polarity connected to point A, which means positive polarity connected to point B. Okay, the same negative side of the cell also has to be connected to point A, and positive polarity, positive side has to be connected to the point B. Remember that. All right, so it cannot be something like this is the negative polarity of the battery, this is the potentiometer, this is AB. All right, you cannot have this cell it's connected to the galvanometer, connected to the jockey. You cannot have something like this, remember. Okay, you're not going to get your desired result if this is the case. Okay, so remember this very, very important thing. Now, so let us continue with the third use of your potentiometer. So after you complete this circuit, okay, what we do is, first of all, we keep the key, the second key, K2, open. That is, you can see K2 is off. All right, and K1 is the only key which is closed. So first of all, that is exactly what I've written. K1 is on, K1 is closed, and K2 is off. Okay, so to say, only this E1 is coming into play right now. Only the first cell is coming into play. If there's any current flowing through the lower circuit, it is flowing through E1. So from A to current comes to C, and it comes through goes through this upper arm because K1 is closed, okay, and flows to the galvanometer. This is not playing any role whatsoever when this is the case, remember. So when this is the case, when K1 is on and K2 is off, so what we have is, say for example, we find the null point at this particular point. When you place the jockey at this particular point, we find the null point. All right, and let us suppose that this distance AJ is x1. This distance is x1. Don't forget AB, the length of AB is L. Don't forget that. So delta VAJ, the potential across AJ will be how much? V by L. V by L is the potential gradient. I hope you've checked the previous videos. So V by L is the potential gradient into x1. So VAJ will be V by L into x1, and VCD will be how much? What is the potential difference across CD? The potential difference across CD, which is VCD, will simply be E1. Why? Because one thing, this is not coming into play, so we need not bother about this right now. And since it is null point, since we've achieved the null point, we've found the null point, there's no current flowing to the galvanometer, which means there is no current flowing through this upper circuit also at null point, remember, only at null point, that is. Okay, so to say, there is no potential drop, there is no voltage drop across the internal resistance R1. Okay, so therefore the potential across CD will simply be the EMF E1. Okay, so therefore delta VCD will be E1. I have explained this point in the previous video also, when we were looking at the first use of the potentiometer, that is to find the EMF of a cell. Okay, that is the second part 2 video of potentiometer. You can go and check that. Okay, so delta VCD will be E1. So therefore at null point, what is true? At null point, when you've achieved the null point, the potential difference across AJ should be equal to potential difference across CD, only then there will be no current flowing to the galvanometer. Okay, so therefore, which means at null point E1 should be, this E1 should be equal to V upon L x1. This is my equation number 1. Okay, then after case 2, what we do is, so far only K1 was on, K2 was off. Now what we do next is, K1 is open, K1 is off, and K2 is closed, that is K2 is on, such that E2 comes into play now. So therefore we have K1 is off, K2 is on, and the moment we do this, what happens is the position of the null point changes, because this is another EMF now. This cell has another value of EMF. Okay, so therefore the position of the null point changes. So you have to understand that. Okay, if you were working with it, you'd have seen this exactly happening. Okay, but so you have to trust me with this now. The moment K2 is closed and K1 is on, the position of null point changes, and say for example the null point is achieved somewhere over here, and shown by this dotted lines, and let us suppose that position of AJ now is x2. This is x2. Okay, so what will VAJ be now? VAJ, delta VAJ will be V upon L x2. Alright, and delta VCD will be at null point again. There is no current flowing through this. Okay, there's no question of current flowing through this because K1 is open. Alright, so therefore only cell that is coming into play is this, don't forget. So therefore, since no current is flowing at null point through the galvanometer, again there is no potential drop across R2, there's no voltage drop across R2, so the potential difference across CD will be the EMF E2 simply. So therefore delta VCD is E2. Now at null point, this E2 has to be equal to V upon L x2. That is my equation number 2. Alright, so we did two cases. First we brought E1 into play, cell E1 into play. Then after we brought E2 into play, okay, by closing the respective keys and opening the respective keys, of course. And first case we got this, and second case we got this. Now what we simply do is we divide equation number 1 by equation number 2. So dividing equation 1 by 2, we get E1 upon E2 is V upon Lx1 divided by V upon Lx2. So this potential gradient V upon L, they divide each other, and thereby we get E1 upon E2 is x1 upon x2. So don't forget, there is a scale attached to every potentiometer. So you have a scale also over here, using which we can measure the respective distances x1 and x2. So the moment we measure x1 and x2, okay, we can find the ratio of E1 and E2. Okay, that is, we can compare the EMFs of the two cells. So this is the second usage of your potentiometer.